Welcome to Maths and Science by IITian channel. In this channel, in my previous lectures on linear algebra and matrices, I have discussed about the addition, subtraction, multiplication of the matrix, matrix operations, Pauli matrices, special cases. I have dealt in detail in the previous lectures. Now, for determining the inverse of a matrix, there are three methods, and one method is involving finding the determinant and then adjoint and cofactors and finding the inverse. And another method is by finding the characteristic equation for the eigenvalues and from the characteristic equation finding the inverse. And third method is by row and column operations by using the Gauss-Jordan method. The easiest among all of them is the row column elementary operations and using the Gauss-Jordan method. Gauss-Jordan method. It does not involve finding the determinant, and you can directly find out the inverse of a matrix by simply doing certain rows and columns operations under certain conditions using certain rules with the help of a augmented matrix. Augmented matrix. Now I want to explain this so that within seconds, maybe within a minute, you will be able to find out the 3 by 3 matrix inverse with simple intuition, with simple column and row operations in a step by step method. But it may not be true for everybody to do it in seconds or in a minute. It requires a lot of hard work, lot of understanding, and quick in response for additions and subtractions of the numbers, and you should be accurate, and you should have sufficient practice to do it fast. But however, I felt, as my personal experience shows, this is the easiest method to find an inverse of a 3 by 3 matrix. Let us go into the details how to do it. What is the given matrix? Given matrix is let us say A is equal to 1 2 0 5 3 5 and 3 7 8. Is it correct? Just see 1 2 0 5 3 5 3 7 8. Now what we are required to do? We are required to find out the find A inverse. Because it does not involve determinants, I thought let me explain this method to you first. Then I will go to a characteristic equation and eigenvalues, explain that method. Then I will go to the determinant and then I will explain the third method. Let us follow this way. Easiest is the first, let us say, in this particular finding the inverse 3 by 3 matrix. It is a 3 by 3 matrix. Now, what will be the solution? First step, write the given matrix in augmented matrix form. What is the augmented matrix? If A is there, a matrix, and I put one small window between A and one I. I is the identity matrix or unit matrix. This is called as the augmented matrix. Now, for this, it is a 3 by 3 matrix. What will be I? I should be also 3 by 3. I is equal to 1, 0, 0, 0, 1, 0 and 0, 0, 1. I is also a 3 by 3 matrix. This is the unit matrix. Now, let us write the augmented matrix. Augmented matrix is equal to, please follow my steps clearly, it will be very easy. A window I, that is equal to, the matrix A is augmented and added I to it. There is no physical addition, it is only a representation, one after the other. A is, what is A? 1, 2, 0, 5, 3, 5 and 3, 7, 8. This is A. Don't close that bracket. Just put dots and a window be opened and you write 1, 0, 0, 0, 1, 0. This is I. 0, 0, 1. You can put the dots or you can put the line also. It can also be written as 1, 2, 0, 5, 3, 5. Either way you can write. That's up to you. 3, 7, 8 and put a line here and you write 1, 0, 0, 0, 1, 0, 0, 0, 1. Like this also you can. Whatever method, whatever way you want to represent, you represent both one after the other. And follow these steps. What is row addition or row subtraction or row elementary operation? After writing the augmented matrix, do simple row and column elementary operations on A, the original matrix, to bring it to the form. A should be brought to this form 0, 1, 0, 0, 0, 1 and same operations side by side applied to identity matrix also or unit matrix also. Then that unit matrix will become the inverse of the A matrix. That is what is the concept. Now, to make a third step, to make A into I the first element of A should be made unity because it is 1, 0, 0. Similarly for other. First element should be made 0, then first row, second row, first element should be made 0, then third row, first element should be made 0. Then you operate and make it. Continue like this. And till you make till you make A to be in the form of I. I can be for 3 by 3, it can be 1 0 0, 0 1 0, 0 0 1, or if it is a 2 by 2 matrix, it is 1 0 0 1. During the process, if two rows or two columns become equal, or one row or one column totally becomes 0, then that matrix is not invertible. Inverse does not exist. It is a very important to be noted, to note during the process. If two rows or columns become same, or one row or column totally of zeros, that implies no inverse exists. This you should know it. Next, let us take the example. I will write the augmented matrix directly without wasting time. 1 2 0 5 3 5 3 7 8, and I put the line 1 0 0. This is A, this is I. 0 1 0 0 0 1. What I will do, I have to make the first element as 1, so that already it is 1. I need not do anything for it. Then the second element in the column, first column, second element, I want to make it 0, because on the right hand side it should be 1 0 0. Then what I have to operate? Let me operate R2 minus 5 R1. Do you agree? Let me operate R2 minus 5 R1. You concentrate on the first column only. Don't concentrate on other things. First column operation. First column operation. First column operation. These are called as elementary operations. First column operation, it is operation 1. And second, what I have to make? Third element of the first column should be 0. This should be 0, this should be 0. For that, to make 3 as 0 means R3 minus 3. 3 minus 3. 3 means 3 R1, because R1 is 1. Are you able to follow me? Follow these steps very carefully. That means I have operated the elementary matrix operation on the first column. What it is going to yield to me? 1 2 0. I have not operated anything on the first row. First row I have kept it because I am using the first row to operate on the second row and third row. On the second row, what is happening? R2 minus 5 R1. R2 means 5. Minus 5 R1 means 5 into 1. This is first element. R2 is 3. 3 minus 5 R1 means 5 into 2. Then R2 minus 5 R1, third element. in the second row, 5 minus 5 into 0, R1 element. This is the operation I have done on the second row. This is done on second row. Consider first column and operate on rows. This is second row operation, this is third row operation. Are you able to understand? When you operate on the third row, what happens? R3 minus 3R1. R3 is 3 minus 3 into 1. This is the first element. R3 here is 7. 7 minus 3 into 2. Be very careful while doing it. Last is 8 minus 3 into 0. What it has become? 1, 5 minus 5, 3 minus 3, 2, 0. This I have not disturbed. This is 3 minus 10. Are you able to follow me? This is 7 minus 6. This is 5 minus 0. This is 8 minus 0. This is the revised matrix. This is for A. And what happened to I? We have forgotten. This is what has happened to A. Then we will write A. A is equal to revised 1. 1, 2, 0. 1, 2, 0. 5 minus 5 is 0. 3 minus 3 is 0. 3 minus 10 is minus 7. 7 minus 6 is 1. 5 minus 0 is 5. 8 minus 0 is 8. Now, because I want to show A and I separately now, and I will add up in the augmented matrix afterwards. I operation. I what is happening? R2 minus 5R1. R1 I am not disturbing. R2 minus 5R1. R2 is 0. 0 minus 5 into 1. 1 minus 5 into 0. R2 0 minus 5 into 0. Here it will be 0 minus 3 into 1. 0 minus 3 into 0. 1 minus 3 into 0. Now what it has become? The revised I is equal to 1, 0, 0. 0 minus 5 is minus 5. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 3 is minus 3. And 0 minus 0 is 0. 1 minus 0 is 1. Let us write the revised A and revised I side by side, augmented matrix. What it happened now after the revision, after applying the operations, first operation, that is the operation step 1. 1, 2, 0. 0 minus 7, 5. 0, 1, 8. And augmented matrix is 1, 0, 0. Minus 5. 1, 0. Minus 3, 0, 1. This is the augmented matrix. Now, my next step is to make this element to be unit. minus 7 should be unit. Minus 7 should be unit, and also 2 should be 0. Follow this only. First I have taken the first column, and I made first element in the first column as 1 and others as 0. Now I am taking the second column. In the second column, what I have to do? I have to make first row, second column, first row and second column element should be 0, and third row and second column should be element should be 0. This and this. I have to make this as 0 and I have to make this as 0. And I have to make this as 1. How to proceed? Because already in the third row, second column, element 1 is there. Instead of doing the operations again and again, we can interchange the rows. Here we'll interchange. One interchange is allowed. We interchange second row and third row, because already 1 is available here. Instead of making minus 7 1, we will shift this 1 to here. We require 1. In the second column, second row, we require 1. Already in the second column, third row, 1 is there. We are just shifting it upwards. And we are shifting the second row to third and third row to second, so that it looks simple for you. You have to use the intuition, you have to use the common sense, you have to use your not only mathematics knowledge, we have to use our common sense also. This is a very, very simple method. It is a very, very simple method. If we use our concentratedly we work, definitely we will win over this. You just see what happens. 1, 2, 0. I am not disturbing the first row in the augment. This also 1, 0, 0. This I am not at all disturbing. What I have done? 0, 1, 8, whatever is there in the third row, I am shifting it to second row, because my basic structure is not changing. 0, 1, 8. Here what happens? Minus 3, 0, 1. And second row is becoming the third row. 0, minus 7, 5. Here minus 5, 1, 0. This is the augmented matrix after the operation of interchange. Now we can apply, because my second row, second column is unity. When unity is there, I can multiply with something and make this element as 0 and this element as 0. To make this element 2 to be 0, what I have to do? R1 minus 2R2. Do you agree? R1 minus 2R2. This is my first operation. That means I have already taken 1 and 2 there. This is third. Then here I have to add minus 7 plus 7. That means R3 plus 7R2. That gives me as 0. You see how simple it is becoming. Now the augmented matrix, I will write augmented and augmented matrix directly. Now you just see R1 minus 2R2. R1 in the first column already 2 zeros are there, so that it's not going to, whether you do operation with R2 in the first column, it is not going to make any difference. For that only we made these zeros first. Now, if we go step by step like this, then you will easily solve the problem. Don't confuse. First you make first column, unit first element and 2 zeros. Then second column, try to do whether you can interchange column and row to get 1 in the second column, second row, some simple value. From that you make this as 0 and this as 0. This is 0, this is 0. Then it will be very easy for you. You see, R1 minus 2R2. R1, 1 minus 2R2 is 0 into 2. That is not going to change first column. In the second column, 2 minus 1 into 2, that becomes 0. R3, minus 7 plus 7 R2, that is minus 7 plus 7 into 1, that is becoming 0, because with that intention only we formulated this. You put directly 0, 0. In between, I am not going to change the second column here. This will be like this only. Now only change will be in the third column. What is that change? R1 minus 2R2. R1 is 0. 0 minus 2R2 will be minus 16. R3 plus 7R2. R3 is 5. 5 minus 7R2. That is 7R2, 5 plus 7R2. 7 into 8, 56. 56 plus 5 is 61. Now, the same operation we have to do in the unit matrix, also adjacent matrix, because we are doing it for augmented matrix. R1 here not 0, sir. We have to be careful. R1 minus 2R2. R1 is 1. Minus 2R2. Minus 2 into minus 3 is 6. 1 plus 6 is 7. I am not changing the R2, hence I will write R2 for clarity. R1 minus 2R2. R1 is the second element is R1 0. 0 minus 2R2 is 0 minus 0. 0 minus 2R2, that is 0 minus 2 into 1 is minus 2. And here if you come down in R3, R3 plus 7R2, 7R2 is 7 into minus 3 is minus 21. Minus 21 plus minus 5, that is minus 26. 1 and 7. This is what we have got in the augmented matrix. Now, what is our aim ultimately? We made 1 0 0 0 1 0 and we have to make these two as zeros and this should be 1. Then our goal is completed. You just see in 2 steps we got this much. Third step we are going to get the inverse. These 3 steps, how fast, how accurately you do it, that is based on your practice. Practice this method, it's a very simple method. You can do it. Now, this implies my augmented matrix, I have written like this: 1 0 minus 16 0 1 8 0 0 1 7 0 minus 2 minus 3 0 1 minus 26 1 7. This is my augmented matrix. What is my goal? I have to make this as 0. This is 61, sorry, it is not 1, this is 61. and I have to make it as 1. My goal is this. I have to make this one as 1, this one as 0. This is my goal. Bring it to unity first. Any element, bring it to unit value so that you can add, multiply that into, and addition will be very easier. Now the step what we have to do is make this as 1. We will make it zeros afterwards. Make this as 1. To make this as 1, you divide R3 1 by 61 into R3. We make this operation. We make this operation for the whole R3. What happens? Let us see. Augmented matrix will be 1, 0, minus 16. We are not operating anything on first and second. This will be like this only. This will become 1. 61 by 1 is 1. And here I am not doing anything for first row. I am not doing anything for the second row. I am only operating on the third row divided by 61. That is minus 26 by 61, 1 by 61 and 7 by 61. This is my augmented matrix. Now I have 1 with me. I will operate very easily. First is first row, first column should be made unity. Then operate on the second row and third row. Make them zeros. Then second row, second column should be made 1. Then operate on the other elements of the second column and make them zeros. Now you make the third column, third row element as unity and operate them on the other rows, second row and third row, and make them 0. This is the process. How simple it is. To make it 0, what I have to do? R1 minus R1 plus 16 R3. I want to operate R3 on R1 and R2. R3 will not change. Minus 16 plus 16 will be 0, so that it becomes 0. Plus 8 minus 8, that means R2 minus 8 R3. These two operations are sufficient for us. This is equation 5, this is equation 6. Now you see, this implies my augmented matrix as 1, 0, 0, because minus 16 plus 16 is 0. 0, 1, 8 minus, plus 8 minus 8 is 0. 0, 0, 1, I am not changing my third row. Here also I will put the third row as it is, I am not changing. 1 by 61. We should be careful while doing arithmetics. R1 plus 16 R3. R1 is 7. 7 plus 16 into R3 is minus 26 by 61. Little bit careful while doing this. R1 is 0 plus 16 into minus 26 by 61. Minus, no, it is 1 by 61. Because we have to do it for this. Third is minus 2 plus 16 into 7 by 61. Similarly, R2 minus 863. R2 will operate. R2 is 0 minus 8 into minus 26 by 61. That is 863. Second will be 0 minus 8 into 1 by 61. Third will be 1 minus 8 into 7 by 61. Please be very careful while doing the calculations. Now, the final will be the final augmented matrix will be 1 0 0 0 1 0 0 0 1 7 plus 16 into minus 26 761. This will be how much? You please calculate. These calculations are arithmetic calculations. You can do it very well. 7 into 61 minus 16 into 26. How much value it will be? That is 11. 11 by 61. Then 0 plus 16 by 61 is 16 by 61. Minus 2 plus 16 into 7 is 112. 2 into minus 2 into 61. Plus 16 into 7 is 112. Minus 10 by 61. I think this will not be a constraint for you doing arithmetics. Minus 8 into minus 26. 8 into 26 is it is minus 3, sorry. It is not 0. We made a mistake here. We correct it. It is not 0. It is minus 3. Minus 3 minus means minus 3 into 61 is minus 183 plus 8 into 26. This value is 25 by 61. Third row I am not disturbing. I will write as it is 26 by 61. 1 by 61. 7 by 61. This value let me clear it. Now second row, second column. 0 minus 8 into 61 is minus 8 by 61. 1 minus 8 into 7 is 56. 1 minus 56 by 61 is equal to 5 by 61. Now, the augmented matrix is of the form 1 0 0. These steps are very crucial. You should not make any mistake in the arithmetics. 11 by 61, 16 by 61, minus 10 by 61, 25 by 61, minus 8 by 61, 5 by 61, minus 26 by 61. I have taken a little bit lengthy matrix, and in the examination if simple matrix is given, you can do it in seconds. This becomes I, this becomes A inverse. How many steps totally we have followed? We have written the augmented matrix. In the first step, we have made first row and first column element as 1, and then we made the zeros first column. And the second step, we made operation in such a way that second row second column is unity, and then we operated on the first row and third row, so that we will get 0 0. Then we made the third row and third column element to be unity. Then we operated on first row and second row and made them zeros. Ultimately, we converted the original matrix into I, and we converted the I into inverse. Therefore, the inverse is given like this. This is the way we have to find out the inverse. And as a homework, I want to give one simple homework. Kindly check the correctness of the inverse. You have to see whether A into A inverse is equal to I or not. If it is I, then our answer is correct. Verification of the answer is also equally important. That means check whether original matrix is 1 2 0, 5 3 5 and 3 7 8 multiplied with 11 by 61, 16 by 61, minus 10 by 61, 25 by 61, minus 8 by 61, 5 by 61 and minus 26 by 61, 1 by 61 and 7 by 61. Whether it is equal to 1 0 0 0 1 0 0 0 1. It will be, but still I have given it as a homework so that once you do maths, then you will learn mathematics. Kindly understand, see it repeatedly if this particular video, and don't miss a single sentence from my side, so that not only in writing I have explained orally how to do it. Please try to do it from your side also, this type of questions. Even though in the question papers or in your textbooks some matrix is given and asked to find out the inverse, try to do this in this method. It is a simpler method. In 3 steps you can find out the inverse. Not much of a difficulty. Thank you for listening to me. Best of luck to all of you in your examinations, especially in the competitive examinations like JEE, Mathematics, CSIR, and also your JEE Advanced Examination and Maths Olympiad. Do well. Thank you for listening to me. If you feel there is a value addition to your knowledge because of this particular method in finding the inverse, please share my video and subscribe to my channel Maths and Science by IITian. Now in the next class we will go for something like complex integral, an integral with complex numbers. How to find out the inverse? That's a little bit complicated, but still we will follow this method and try to find out.